好了。哦，不对啊，可以，就这个是吧？
对，第一个问题，对，
好，对，行，好的。那我们下午的活动就正式开始了。然后，我简单自我介绍一下，我是 AWS 这个 Web3这个团队的技术负责人，是架构师的这个团队的负责人。然后叫 David，中文名叫毛丹龙。对，然后我们团队的话，因为整个安卓的话，现在基本上分成了大概是8个行业。然后我们团队的话是专门服务这个 Web3这个整个的赛道的。包括里面的这些交易所啊、钱包啊、量化包括这些那个做市商就是因为我们只做这个 Web3这个赛道里面所有的客户，对，然后我们团队大概主要是有一大波人是在香港团队本地，然后另外一波人的话是在这个新加坡，然后我们在这个里面的话大概是积累了，也是在 Web3这个赛道里面积累了很多的一些解决方案，也包括这个做数据分析解决方案，然后做这个安全的解决方案。做包括我们最近做这个支付，然后人民币相关的一些解决方案，然后我们也给所有的交易所呢提供这个安全的一系列的这样的一个技术方案，然后我们内部也有整理的，比如说像这个安全的这个评估，对，然后包括怎么做好这交易所，怎么做好这个交易所的这些安全，然后另外的话呢，还有一个很大的一个大头是，我们团队也会做类似撮合引擎的这样的一个技术方案。对，我们会跟很多客户去聊，撮合引擎里面的整个的H3 的架构，然后撮合引擎里面的很多的批的细节，比如说数据的这些内存的判断，应该怎么样可以更快、更好、更便捷的维护好。也所以，另外的话，我们也会帮我们客户们去做这个撮合引擎这个调用的优化。对，然后除此之外，还有一个很大的一个环节是，我们其实也整理了非常多的一个大数据方面的一些解决方案。那这一块的话，其实我们在整个生态里面。那也会经常跟我们的这个合作伙伴，比如今天在场这个 Tacnode，还有这个图数据库相关的这样的一些这些 partner 呢，整合在一起，就形成 AWS 的自己在 data 这一层的这些 solution。所以，我先做一个简单的开场，然后待会儿我们的这个架构师聂鲁同学会跟大家去介绍一下我们这个团队大概会做哪些事情。对，那简而言之的话呢，是说。我们现在因为我们这个 Web3这个客户的这个数量足够大，对，因为我们几乎除了因为我们这个团队也比较幸运就几乎就是整个 Web3赛道的所有的交易所，其实大家都是选择了 AWS，所以我们专门为了这整个 Web3生态里面呢，我们也组建了一个 dedicated 的一个团队，所以我们是不做其他这个业的，我们只做 Web3，然后做 Web3里面的所有的赛道，然后其他团队的话，他们也会做 Web3。对，所以我们是比较纵向子，然后在这个行业内部积累的比较多的一些技术的一些解决方案。我先做一个简单的一个开场，然后我们这个六同学会详细介绍一下我们在这个领域里面我们大概整理的所有的技术的内容，以及我们做的一些 case 的一些分享。好的，再次欢迎大家来到香港红龙湾 Office 的这个现场，谢谢。
OK， 好，谢谢毛老师。好，那我们现在进行第一个 session 我叫 Neil 我是 AWS 的资深解决方案架构师，专门负责 Web3的架构以及相关的一些设计。那首先今天也非常荣幸各位我相信各位都是 Web3领域的爱好者，或者说是一些专家吧。我们来分享一些 AWS 在 Web3领域的一些最新的进展，一些我们的跟客户的实践的经验。那接下来我会用30分钟时间来跟大家分享 AWS 如何在 Web3 行业Web3 生态吧提供这样一个强有力的技术支持。首先我们看一下今天会议的一个 agenda， 比较简单就第一部分我会讲这个AWS for Web3 的平台优势以及平台能力。那我跟大家会介绍一些 AWS 在行业内的独特的价值。那第二部分呢，我们会围绕 Web3 生态的解决方案，这部分我们将通过真实案例向大家展示我们 AWS Web3 团队如何解决相关的一些技术核心挑战的。好。那我们首先看一个最新的一个权威的这个数据就是这个 Tacnode 的这个最新发布的战略云平台的这样一个模拟象限。那大家可以看到，其实 AWS 已经连续15年稳居领导者象限的右上角这不仅是 市场地位体现也表现了我们也是有超强的这样一个技术能力和前瞻性的愿景。那这里我把它分为三部分啊。首先，第一部分它的原因是我们有足够大的社区的云社区的一个体量，大概数百万我们的客户在我们平台上，同时我们还有数万的这样一些 partner 在不断的跟我们去提供更好的补充的这样一些方案和我们当前的产品融合在一起。那第二点核心优势是Amazon 自己的自研的芯片啊，那这里会分为叫 Graviton。还有我们的专门训练的这样一些性能芯片。那第三点呢，就是我们其实全球化的优势啊，我们 Amazon 相对于其他的这些运厂商来说，会有最全面的这样一个基础设施以及生态系统啊。那另外也是在 echo 一下刚刚Damon 说的那个信息啊，其实95%以上的Web3的行业，特别是交易所 CEX、DEX 都是构建在 AWS 上，所以这个指标能给我们一个比较独特的视角吧，就是我们几乎拥有了整个 Web3行业的这个全景图。我们知道不同层级的客户，无论你是刚刚 start up，还是说你已经一定体量，或者说你现在是一个头部，或者说正在欣欣向荣的这样一个 CEX，我们知道你的各种场景以及不同子类的在这个行业内的需要成长需要的这个技术栈。那也通过更多的像技术交流啊，比如说我们的做一些架构评审，甚至还有一些我们跟客户有很多客户啊，比如说最头部那家，其实在亚马逊，他们一 start up 的时候就在亚马逊上，所以整个系统的演进过程我们都知道。我们也是陪客户从初创到现在这个最大的这个规模的全过程。那这个过程其实让我们积累了这个大量的这样一手经验。那这些经验让我们能够深入了解吧不同阶段的这个Web3架构应该如何去选型啊，性能上可能会遇到哪些瓶颈，你应该如何调优，再到技术上的困境你应该如何突破啊。OK，OK 好，那基于此的话，我们再下一下，就是我们可以看一下当前的一些具体情况。大家可以先看一下右上角啊，那实际上我们在各种排行榜你看到啊，这是前20甚至更多啊，绝大多数都在 AWS 上运行。那这里就得看到本身亚马逊的整个的一个全球的覆盖面啊，一共有33个region，105个可用区，都是这种超低延迟的访问啊。同时，我们其实还有个很大的优势，就是说400GB 的这个骨干网络啊，让区块链的本身节点快速同步等等。那除此以外呢，还会有像41个的 local zone 的这种，像你如果是一个高频量化机构的话，那你可以甚至在接近就交易所的机房里同样做这样的事情，让你的延迟降得足够低，缺少就不会再有那种滑点的效应啊。当然还有一些像更多的边缘节点，更多的这种专线的接入，让你的延迟可以降到亚毫秒级别啊。那这也就是为什么这些交易所像 Coinbase、像币安、像火币、像百币的等等若干这么多所选择 AWS 的原因。呃，另外大家可以看到，其实我刚刚上面有标记这种大的图标啊，那这些交易所所在的这样一些 region，你会看到美洲、欧洲、亚太，其实每个金融中心他们都会有覆盖啊。对，那另外一点就是说，其实 Amazon 并没有就此停步啊，就此停滞啊。那随着往后的过程中，其实还有更多的新 region 在开立出来，方便大家更好的去跟当地的 local 用户去进行一些线上的一些活动。好，那除了基础设施广度的时候，我们现在看看阿 m a 在技术深度上的一些创新啊。最具特点的其实是我们自研的一些芯片啊。那首先是 Natural 系统的这样一个芯片，那你会看到我们其实在这个部位啊，我看能换上，对，在这个部位你可以看到我们其实会把这个硬件虚拟化层的 Natural，我们把它做了更多的一层加速啊。你看到带宽其实达到了200 Gbps 啊，那同时延迟比相对于之前再去降低50%啊，那同时存储的延迟也会大力降低啊，那等等以上特征保证了我们所有在亚马逊上的服务都能够快速的响应跟底层进行交互，同时有更高的安全性和容错性。那其实你可以看到，从 Nitro 1到 Nitro 5的研过程中，我们其实也是在不断突破极限啊，不断突破极限来为 Web3高性能打下一些坚实的基础。OK。好，好，另外一块就是说，基于 Natural 芯片，我们上面搭建的这样一个叫 Graviton 的系列的这样一些处理器啊，那你可以看到，我上面列了很多这些组件啊，大家可以看到啊，那这些组件其实非常多都是像我们的 Web3行业会关注的，比如说像 Redis，那 Graviton 就可以比 Intel 再提升59%的性能啊，那再到 RocksDB 吧，我想很多组件大家可能多多少少也会用到。那如果你用的是我们的 Graviton 芯片，那它会在标准的这个产品上性能上再提升75%啊。 那以及 Flink 啊，像 MySQL 都有类似的这样一些性能提升。但与此同时啊，就是性能提升的过程中，我们的成本会更低啊，成本只有原先你如果用英特尔成本的50%。所以这个场景上你会发现，像一些头部的这些企业啊，我不说它的名字啊，他们因为替换了这一层原先用英特尔芯片，改成了我们这种最新的这种Gravity 的芯片，增加了它 redundance，它可以搭2套，它可以搭2套提升 redundance，同时它的性能还有些许上升，成本其实不变啊，对。这是一个非常好的一些点吧，微服务的整个一个替换的一个场景。那随着一些本身的性能提升，包括延迟降低啊，那很多的量化客户也开始选择用 Nature 芯片来做相关的一些活动啊，包括一些我相信我们的 partner 也会有一些测试啊，就是你如果原先的基于这种 X86架构，你切换成了这个Gravity 之后都有显著的这种性能提升。那你可以看到，就是除了就是我说的这种基础设施的这些组件以外，其实阿布 m 绝大多数产品都开始接受基于接受基于我们这 Gravity 的这样一些组件嘛，比如说像数据层，像高速缓存啊，包括图数据库和我们的这个容器层啊存储，它们都会有相应的这样一个提升啊。好。那我们再说回到生成式 AI 啊，那这个其实是阿姆龙你可以看到一个比较代表性的一系列组件产品吧。那首先灵活性啊，那阿姆龙在上面你可以选择足够多的模型产品让你足够选择，就像本身阿姆龙本身的线上超市一样。那再次安全性，那为企业也会定制各种基础啊，保证数据的安全。那再其次就是说成本效益啊，那我们会有专门的，还是刚刚一样专门的这种芯片，特别是 training 啊这种训练芯片来帮你做训练、帮你做推理等等，来提升整个的一个性能。那当然也会包括完善的整个一个链上的 AI 的工作链啊，比如说像我们的 Q 系列啊，如果是你的开发，你是商业活动，或者说一些其他的在 BI 方面的一些组件，当然还有像基础设施、Agent、图数据像知识库等等，以及风控等等，我们都会做了一个完善的这样一层架构体系啊。那这些其实也是现在越来越多的客户选择阿姆龙来构建他们在云生态的这样 agent 的一个前提啊。OK，好，那我们其实刚刚快速啊，我觉得花了可能几分钟时间吧，我们快速把阿姆龙本身的基本的这样一个能力做一个快速的回顾啊，和一些基础知识的基本概念的一起补全。那我们今天进到今天的一个重点嘛，就是说Web3行业的典型场景以及解决方案，我们是如何做的？那回到真实场景中，看看阿姆龙提供了哪些解决方案和落地的一些案例啊。那首先是安全性和合规啊。那其实对 Web3来说，安全其实是所有客户的生存的一个基础啊。那这是一张完整的 Web3安全架构的这样一个路线图啊。我们从这个 Quick Win 快速制胜，一直到这个基础配置，到持续高效，再到日续完善啊，我们会分这几个阶段。那同时在场景上，我们会把所有客户他在线上可能遇到的一些需要注意的问题，比如说它的公网，比如说它的本地开发环境，它是否开启了多账户管理以及危险行为检测，再到基础设施的防护AWS 的安全防护是否已经都做完善了，以及数据安全、应用层安全，再到数据库和 CI/CD，再到容器化和孤档隔离，我们都做了针对性的这种场景的拆分。那针对这些场景拆分之后，再分为不同的阶段，我们来做整个客户的一个整个客户的安全的一个体系吧。那这里我不一一展开啊。那这里其实我们会更多的把这个跟客户去case by case 去聊啊，因为每个客户会有他的这种历史包袱或者是一些本身的一些固有的一些特征在里面，他可能不一定能全部采用所有的都是最佳，但是它也是有一个方向吧，或者说哪些地方我们一定要做到。比如说让我看来，就几乎所有的这种腰部以上锁啊，就是前20米以上的锁，你都应该达到这个第3阶段的这样一个安全性的这样一个水平啊。对，那今天其实时间有限啊，如果大家对这个安全场景有一些感兴趣，或者说想细聊的话，我们可以等一下再茶歇再详细聊一下。好，那这是安全层面啊，亚马逊提供的一些细节。那我们再到合规性啊，那其实 AWS 拥有业内最全的这样合规性的认证啊。那这张图上你可以看到有30多个国际认证，那这里包括ISO 系列啊，各种，然后再到 SOC 啊，再到 PCI 再到什么区域性的，比如说日本的 FISC 啊，到新加坡的、德国的。那这对企业其实 Web3企业意味什么？就是说只要你选择了 Amazon，你就可以自动继承以上这些产品的一个合规性的这样一个标准。 那同时也降低了你本身的一个审计啊。那针对于您的审计员来说，他只需要引入 AWS 的这个认证报告，那他就完成了这样一个合规性的这样一个过程。那同时，因为我们已经包含了30多个吧，整个国际认证的不同区域，所以对你来说选择上可能会更简单一点啊。那其实有一个真实案例啊，就说有一家所吧，就要进入日本市场，那首先它要满足这个 FISC 的这样一个金融标准，那其实 AWS 已经有了，那它只需要关注在应用层面的一个合规性就可以了。那对他来说，创始人反馈说，因为这个事情给他节省了6个月的时间啊，节省6个月时间。那我们其实除了提供了刚刚强调的这些基础设施以外，在更多的一些安全合规性，也可以帮助 Web3行业和企业它更好的去快速开展业务，全球业务。OK，那我们再下一个点就是我们看一下今天的我觉得比较核心的点吧，就是聊完了 Web3的安全合规，我们看一下交易所最关心的一个话题啊，就是说如何构建这样一个超低延迟的这样一个交易系统啊。那这个其实是Coinbase 在2023年的 Ring One 上它公开的这样一个我们的撮合引擎的这个架构啊。那这个架构仍然具有典型性啊，我可以告诉大家，到现在这个时代即使已经2年过去了，仍然具有先进性。那它的一个核心设计理念呢，就是说基于Cluster Placement Group我们简称叫 CPG 啊，就所有的这些设备尽量在一个机架上，但是来做最小的网络跳转以及最低的延迟这样一个延迟的一个保障，同时还有10 GB 的这个网络的一个带宽的一个上限在这里做保障。那同时你看啊，其实我们看这个右下角吧，那整个组件它其实分为从了 Gateway 进来之后就会有柜台，柜台完了就是它的撮合引擎，其实中间它是没有 MQ 的。那通常来说，我们看到可能中间会接一个 Kafka 或者一些其他的 MQ 在这里啊，但实际上你加了 MQ，你的延迟一定低啊，所以它把这层就去掉了。那同时这里的每一个组件它都是基于 Raft 进行连接啊。那因为 Raft 本身我们其实市面上能看到的 Raft 都是基于 TCP 的。那我们都知道 TCP 跟 UDP 的速度可能差了10倍啊。那它会基于 Aaron 再做一层改造，所以说这里面的每一次确认它都是基于 UDP 来实现。那我可以跟大家就是描述一下整个过程啊，然后我们再说它的性能有多快。那正常来说，一个客户从 Gateway 进来，先订到我们的柜台系统，柜台系统的这个 Leader 上，Leader 拿到之后，他会在它的内部做一些日志记录，以及把这个去保存预存一下它的这个状态，我们叫做状态机啊。那这个过程中，他会把当前的这条消息，或者说这一批消息吧，这一批人的下单，他会给另外多个这个 follow 去往下发。它正常来说到3到5个啊，那3到5个里面有一半以上，也就是说这个情况下应该再有一个，或者说5个节点有3个节点返回过来，它才会做确认，然后再往下走，再把这个订单给到 Match Engine，给到 Match Engine 之后，那这个 Match Engine 它在撮合的过程中，它也会把它当前接受到的这些撮合需求发送给其他的这些它的 follow 节点啊。那这些节点你可以认为他们也做了一层撮合，同时把结果再返回过来，跟这个 leader 结果去进行匹对多数节点返回之后确认之后，然后再往回传。这时候这个 OMS 会接收到什么情况下？比如说你下单啊，比如说你下了一个 BTC 的单，但通常一个 BTC 不会直接成交，它一定是0.几成交，所以这里一定有非常多的再交互过来，再传回你的 OMS 上。那这时候它再来一次这样确认，然后再传给你的这个你当前的这样一个 gateway 上。那整个过程，我们当然这里还有很多优化，包括细节上。那实际整个过程端到端的延迟啊，客户可以做到 P991 毫秒，P991 毫秒。大家可以评估一下，对，基于 UDP 以及我们当前的整套极致性的改造，它可以达到这样一个水平。那为了满足这个需求，其实还有更多一层场景啊。我觉得我们可以带到未来的机会，我们再一讨论。因为如果在 CPG 整个节点，其实安全性是没有保障的。比如说整个机柜当掉，那你的这套就没有了。那他们的方案是，它会跨 AZ 去再有一份这样一个 backup，也是基于 Aaron 啊。当然，甚至还有一个他们基于跨 region 还有啊，它会做的非常极致啊。但这里我就不多做一些阐述，多做一些阐述啊。另外就是说。客户在整个研究过程中可以保证的一点就是说，它的跳转啊，只有10跳啊，只有10跳。当然还有很多一些，比如说内存化呀，包括 kernel bypass 啊，包括一些 DPTK 的概念，在容量里面去加快整个一个流程啊。所以从我的角度上来说，可能当前的这个架构来说是绝大多数锁的一个标杆性的架构啊，哪怕是现在最强的锁啊，他们是自研啊，但是也是近似的这样一些特征去做优化，当然可能做的更极致啊。OK。好，那这个是 撮合引擎，我们再看看量化交易啊。那量化交易其实针对本身的量化逻辑，其实客户通常作为最高机密存在，但是他们唯一最 get 的点就是说，怎么样把我这台机器撮合机器跟用户的机器的距离能够足够的近啊，甚至说我只能买到你附近的这样一个机架或者说接入点啊 POP 点上来完成这样一个动作啊。那这个里面其实也会用到更多的一种 Amazon 这样一个技术，比如说你用到 Amazon 的Direct Connector 啊，尽量去保证你的共享网络的一个延迟保证啊，然后还有更多的一层像服务器层面的一些 LU，比如说还有一些我们像 Numa 各种内存上的一些调教，尽可能让它的决策以及它的响应能够足得快到达对方的对方这台 ARB 吧，就进入到对方的这个 WebSocket 接口去做下单和承担整个一个过程啊，对。那这里其实还有一些更细的点啊，更细的点就是整个做法。总之在量化上，我们跟这些市商啊等等都会有更多一层交流接触啊。所以说，如果您也是一个量化的机构人员，我觉得我们可以接下来会更多话题去探讨啊。OK。呃，对，那这里可能讲的一些技巧吧，就尽可能我们怎么样去把我们的机器尽可能的散到客户的这个 ARB 附近，然后完成我们尽快的一个下单和这样一个HA 的保障等等细节上啊。对，这个我就先跳过吧。好，那我们讲完了这个交易所的撮合本身安全，我们还有另外一个点啊，就是说海量这种链上数据啊，包括客户本身在处理过程中，他一定会需要遇到他的这个数据分析场景啊。那怎么样他去做风控，怎么样去做一些挖掘实时分解，那也是我们当前其实一旦你的交易所达到一定规模啊，你一定会考虑的一个话题啊。那其实每天大家都会跟数据会打交道。OK。那这张图其实就展示了 AWS 强大的这样一个数据分析能力啊。那这里我们先看中间啊，等一下再看我们的 pattern 啊。那这里我们会有若干的这样一个数据接入源呢，比如说您可能会有自己从外部来的流量啊，就是 data source 啊，或者是一些 IoT 啊，或者您本身的这个 app 的流量等等若干的这些流量。对 Amazon 来说，我们会把它存储在一个各种像我们的 Aurora 专门数据库啊，包括 Redshift，包括各种我们的这个 NoSQL 啊，甚至 S3上啊，我们会做一个存储和查询。那除此以外呢，我们会做一层基于比如说 Glue 啊这样一个数据集成啊，再把它吐到下一步的这个数据分析这样一个组件上，比如说也是 Redshift 的 EMR 等等若干这些组件啊。当然，整个过程我们会做的，当前场景会做的更加的 smooth 啊。我们把这个格路已经替换掉，我们实现这种 zero ETL 形式，也就是说，一旦数据写到了你的这个关系数据库，它就会自动的同步到我们的这个 Redshift 等等这些展品上来啊，等等若干。那这套流程其实做的非常的，也是非常的客户大家认可吧。那当然还有下游的数据吐出啊。但与此同时，我们发现还有客户需要一些更细节性的，或者是更适合他业务的这样一些功能啊，包括一些特别苛刻的这样业务场景啊。那这里就不得不提我们的就 partner 啊，在每个个性化场景上，他们都会有更多的一层数据的摄入啊，数据的一层给我们整个这种云上组件去更进一步去把它用好啊。OK，那这里可能会分很多啊，比如说我们的整个一个打点啊，那这里若干的一些企业啊，比如说我们的HTAP 啊等等，像我们的 TiDB 啊，也会有我们的Tacnode 啊，今天我们等一下会听到。那以及我们接下来的这个在 Action 的这层很多的一种操作啊，包括一个你怎么去快速查询，以及若干的其他一些我们的图数据库啊，怎么去跟客户去做一些风控的操作等等。当然还有 MQ 啊，去降低原先的这种高成本的这样一个情况啊。OK。那再稍微 hack 一下，就是说整个 Web3其实特点就是说数据量其实体量非常大，实时性要求非常高。数据量大到什么程度啊？就是一天可能有几百 几百 TB，甚至有的有高达1 PB 这样的数据啊。那你需要一个很健壮的组件去承接它，并把它去尽快的去产生价值。一个数据停住的时间越长，比如说你这个数据可能呃你隔1个小时才分析出来，但它的价值其实是非常低了啊。对，所以我们要求的就是体量要足够大，才能概括足够的这样一个当前现象的特征，同时还要时效性足够高，那解决本身数据的一个复杂性问题啊。那Amazon 跟我们的 partner 一起啊，那从数据的采集，再到数据的存储再到数据的分析，再到数据的一个产生这种 action 的完整的工具链啊，让这些 Web3企业能够构建出这样一个高效并且实时的区块链的数据分析平台以及风控等等若干这些平台啊，也为量化或者风控 还有市场洞察提供这样一个提供这样一个强大的能力啊。好。好，OK，那接下来我们再进入另外一个领域啊，就是生成式 AI。那生成式 AI 其实当前在Web3行业也越来越普遍啊，因为他们本身针对于技术的先进性就非常的推崇啊，我们需要更快的掌握一些当前最新的技术。那 Web3显然就是当前最新技术的一个标杆啊。那这里你可以看到，其实，在加密货币行业，这只是一部分啊。就比如说像社区智能，我们能不能在这里面更快的把一些客户的一些讨论、一些信真变成一些热点去传递出去啊，甚至跟我们的本身交易所的这些自媒体去联动起来啊，做一个互动。那再到我们的AI 投资顾问，那我们这里可能会有更多的一层，更多一层基于你现状的，比如说基于你现有的这些。这个持仓，包括你的这个搜索这些提问去做很好的这样一个交互啊。那这些其实你在一些交易所的这些软件里已经能够有这样类似的一个这样一层交互的这样一些内容啊。那当然还有推荐系统啊。那基于我们当前的基于真 AI 的这种推荐系统，效果我们发现明显要比原始的这种传统的推荐系统要更加迅速啊。那以及再到这个对话式的这种 AI 啊，再到我们的这个风险控制啊，再到知识库等等。那这些客户都是传统上都在做，都在完善的一点啊。那我相信可能在座各位也会有类似这样一些话题，但是我们希望其实不止于此啊。那有些更新的东西也是我们架构师跟客户一起联创的啊。那我们就看看最新的东西他们能做到什么地步啊？那这个其实是我们当前跟一些头部所一起联创的，基于生成式 AI 来做真正量化的这样一个量化因子的这样一个方式啊。那这里你可以看到我们是基于 Kernels 这样新的这样一个K 线的这样一层这样一种大模型吧去构建了一个实时买卖的这个系统啊。那什么是 Kernels 啊？那简单说一下，它是一个金融市场的这种语言模型啊，它把 K 线当成一种语言吧，类似 GTP，我们来预测下一 K 线应该怎么样生成。那也专注于本身时间序列建模啊。那这里其实说，在 Amazon 本身会做哪些创新啊？基于这个模型，我们会把K 线让它生成的是买卖信号。那具体来说，我们会把它当成一个多分类七分类的精准的一个分类来做。那另外一个就是自适应的买卖点的判断啊。那这里我们会跟客户做到就是简单固定的阀值，但是根据市场波动来动态调整。那这个其实非常难的。你会看到传统的这些指标，比如说你用了 MACD、KDJ 等等这些指标，它很多要不就是未来因子，也就是说你可能当时看到这个 K 线。它标志是买或者标志已经金叉了，但是实际过了一段时间，你发现那个金叉又不见或者变掉了，这是不太好。这些指标对我们来说其实都不是特别好的指标，就一定要这个指标就是当时它不应该包括未来因子，就是当下的所有的指标，包括它历史窗口作为它的输入，你才能决定当时你是否真的去买卖，否则的话它会有更多一层变动啊。那再一个就是说，我们基于这种分类的这种任务我认为是巧妙的融入了这种自回归的这种模型啊，通过这个 Hyper Network 去不破坏原本的这种 K 线生产能力情况下，增加买卖点预测能力啊。那我们核心看一下我们整个一个结果啊，我们看一下实战结果。那日内收益啊，这种长周期的日内收益啊，这个 我们的 Kernels 的这个指标大概能达到0.91，0.91，差不多一天是1%个点，对，一天一个点。而且这个模型其实我们跑的时间并不长啊。另外，你可以对比一下其他指标啊，像就是平均下来啊，这个收益率像 MACD 啊不宁带，当然这是优化之后的，那是负的啊。那我负的也很正常，证明它的指标，也就是说反过来说啊，就是如果你真的拿这些指标去做，你不太可能赚到钱，因为他们在长周期来都已经负的，或者说随机性太高了。那当然这里还有一些基于经济学统计的一些指标，比如说你看到强买信号，我们的准确率大概86%，强卖信号大概75%啊等等，包括我们的 F1的 source 啊0.814啊，这些都是蛮好的指标。同时我要跟大家其实开诚布公的是，就是这个模型只用了非常小的一个24GB 的一台 GPU，我们只训练了十几个小时就完成的结果。对，这个其实非常想象力啊，所以我在想，如果大家对这个话题感兴趣啊，那可以跟我们进一步的探讨啊。如果你可以用更多的资源，甚至你更多的维度，我们把更多的去联创，把你的经验再融入进来，我相信它的收益率会更高啊。那我们最新拿的结果没有放上去啊，就客户能做到日内是4个点 BTC 的5分钟 K 线啊，这其实非常可观的啊。对，OK。对，反正强调一点，这是一个初步结果吧。我们相信就想说，其实不只是这些啊，只要你有的Amazon 我相信都能跟大家去联创去做新的一层输出吧。因为我们内部其实非常多的 PhD 啊，对，跟大家一起做 这方面的一个研究和探讨。好，OK。那最后我想用这张图来总结一下，AWS 在 Web3行业的使命和承诺啊。那首先，我们的使命就是说，赋能 Web3行业的开发者和创业者，那共同创建和定义互联网的这样一个未来啊。那当然也为了这个实现目标，我们会有2层的这样一个数据或者说平台的支撑啊。那首先就是 AWS 的基础设施的核心的这种价值啊，那最强的这样一个稳定性以及保证业务的连续啊，或者说超低的延迟啊。我们刚刚强调 Nature。那业内最快的延迟，保证最低的延迟来保障高性能的交易需求。那再到我们的合规性以及我们的这个服务深度和广度啊，那保证所有的产品再加我们的 partner 呢一起来跟客户跟大家来提供最完善的这个技术的一个一站式的平台。那第二一点就是说，我认为是本身的 Web3这个团队啊，因为我们当年团队其实是来自香港、来自新加坡，但很多其实是来自国内最顶的这些真正的技术专家啊。那不仅有其实精通就 AWS 技术啊，那也非常深入在 Web3行业的挑战和机遇啊，包括我们刚刚很多细节，其实也不是这一次跟大家展开啊，是需要每个再剖开来讲的。比如说你当前的客户的架构，你当前的错位，你应该怎么样去进一步去演化，包括你当前的真 AI 下一步应该怎么做，怎么样才是真正的行业顶尖啊，等等若干吧。就是我们会相对于其他这些云厂商来说，我们有更好的全局视野啊，能看得更多。包括你会看 partner 呢，也是 Amazon 平台是最多的。那我们承诺的是跟您，包括跟 partner 我们一起并驾齐驱，我们去把您的创新点去变成现实啊。那最后就是感谢大家聆听嘛，也非常期待未来跟各位 Web3的创业者，包括我们的 partner 进一步去交流，去更深入的去完成我们接下来未来可能10年5年的这样一个业务版图。好嘞，谢谢大家。嗯，好的下一位是哪位老师？OK OK，好，好，给你带个风啊，你在电脑吗？就是电脑啊，我电脑。
我眼睛转播视就好了，这样就可以了。你在能看到什么吗？OK 吧？Sorry for the interruption. Yeah, I got to deal with the live stream problems. Okay, so let's get back to the topic. So in the lakehouse, the system serves as an offline feature store, storing processed features derived from raw data through cleaning and transformation. So while this works fine for historical analysis and machine learning uh, training, but it doesn't provide instant access required for real-time AI inference. So where features must be updated and queried on demand. So let's think about the AI inferences. It always use online feature store. So the system is designed to serve. So we need to what happened? Doesn't work. Okay, fine. Okay. So for real-time AI inferences, online feature store is required. The system is designed to serve real-time features to AI models with low latency access, ensuring that features are continuously updated and available for instant predictions like fraud detection, recommendation, and dynamic pricing. All of these scenarios are time sensitive. So as you can see here, we're separating the offline store from online storage, right? This kind of separation introduces challenges in data synchronization, as real-time features must be exported from offline feature store. It takes time. This kind of synchronization introduce delays between different systems. And to address this kind of challenges, to reduce the delays, developers often bypass the synchronization by using streamwork like Apache Flink to bypass it, to use Flink to feed the updated feature directly from the source to the online feature store. So this is what's happening right now in the technical society. So in next slides, I will give an explanation on what the specific problems that arise from this architectural gap. You see that these are actually two architectures. The first one is offline architectures to dealing with offline features, and another one is real-time, paths to deal with real-time features. So what's the problem with modern data processing systems? So once a real-time systems enter production, they don't just need more data. They need the right data in the right moment. Okay, so this is the key. This is actually the conception of context. We call it context. The context is data in motion, shipped and retrieved for the specific decision at hand. So this is why we call it context. Context is not just a long. It's a dynamic conception. Okay, so the problems that we are facing right now, I mean, for the traditional data infrastructure, is that the first one is stale data. We not only AI models, but also BI applications, they need fresh features to make decisions, to make the inference, job. But the lakehouse process data in multiple stages. As we all know, lakehouse dealing with data by by batches, one batches at a time. That incredibly introduce delays. That is the nature of the data processing model of lakehouse. We cannot change it away. So stale data is the first challenges by using the current infrastructure lakehouse. And the second one is a complex pipeline. As you can see before in that diagram, there are lots of lines between applications and database systems. So that each of the line represent a pipeline job. It's so complex. The complexity of pipelines introduce many problems. So introduce delays is the first one. Another one, if you want to add external pipelines, it will involve many, external jobs to manage this kind of streaming jobs. It's very time consuming. And the third one is retrieval efficiencies, because here the BI workload and AI workload, they need to retrieve data from databases, from OLAP engines. So, right? But sometimes there are lots of data sources, various data sources, such they can be structured, unstructured, semi-structured, or even vectorized, right? So the engine need to be able to dealing with all this kind of data sources, but current systems, they fail to do that. They can be efficient in dealing with structured data, but not that so efficient in semi-structured data. It's a combination of all of the multimodal retrieval. So less system can do that. So this is the problems with modern data, their processing systems. So this actually introduced the core concept of our technologies. We call it Tacnode context lake. Let's assume that in an ideal system, all the data, raw data, offline features, online features should exist within one single unified platform. This is the best choice, right? And this kind of compilation eliminates the need for complex disconnected systems and reduce operational overhead caused by managing multiple systems. And more importantly, it improves the data freshness. Okay. But this is hard work. This is not so easy. What I just mentioned before, we put all of data together and we provide a unified platform for data retrieval. This is actually the concept. This is actually the core value of context lake. Tacnode raised this concept this year. So we have a trademark for this concept. So we get back to the context itself. The context lake is actually aims to lay the foundation for instant intelligence. Let's just take Web3 scenarios, for example. It could be fraud detection, could be anti-promotion abuse, it could be anti-money laundering. All of these scenarios is actually time sensitive and mission critical. So speaking of context lake, there are three most distinctive features that the context lake can provide. The first one is the ability to act in real time, to ingest the data, transform data, and retrieve data in very real time. This is first features. And the second one is to provide fresh, actionable data for both people and machines. As we know that AI workloads are actually consumed by agents, lot kind of agents, right? And the BI system are usually used by people itself. So the data from context lake should be able to support both of these kind of different scenarios. What's the difference between these two scenarios? The first one, people, the consumer is human, the latency as well as the freshness is not so much critical. But if it's consumed by agent, a lot of thousands of agents itself, right? So the latency as well as the freshness and the concurrency is a crucial problem. It's crucial, so crucial. So total different methodologies. And in the next slides, I will explain how we built such a system, how Tacnode will build such a system to address this kind of all of these challenges. So I got to mention a basic concept that is Postgres. So does anyone ever heard about this concept, this product, PostgreSQL? Anyone? Okay, never mind. Okay, so PostgreSQL actually is a famous database. It's a kind of ecosystem. So at Tacnode, we have taken the familiar Postgres experience and built it for real-time, high concurrency demands for model AI. So just in a simple word, the traditional technology like Postgres isn't built for the high concurrency, low latency environment of Web3 industries. So we reimagined a new engine to address these challenges. That is what we are doing. But the technologies, the foundation of the technology is totally different. It's totally different. Okay. So, but to keep our customer adoption smooth, we choose to comparable with Postgres ecosystems. And with this kind of compatibilities, we extended the scalability of Postgres systems, and we rebuilt it to make it suitable for real-time AI and BI applications. That is what we have done right now in just one word. Okay. So yeah, we compatible with Postgres. All of the tools, frameworks, as well as the BI tools can be compatible with our product. So if you are using Postgres database system, you don't need to change anything. You don't need to change the applications. You don't need to change to another tools. Everything is smooth. Everything is smooth. It just works. Okay, so why we choose Postgres benefits? I think there are lots of reasons behind this, but the most four distinctive ones is to be multimodal, because as I mentioned, there are lots of different data types like semi-structured, structured, vectorized, or even a text, image, totally different data sources. So Postgres is able to support multimodal retrieval. That's why we choose it. Okay, the second reason is it is supportive of many advanced query abilities like complex join, like aggregation, like window functions, which are essential for complex queries that always be used in Web3 industries. Okay, the third one is comprehensive indexing. This is most important because in most case of scenarios, you need to depend on the index to accelerate the query. Okay, so the fourth one is strong consistency. Consistency is a mandatory requirement for database systems because if you want to make the right decision, you need the accurate data and reliable data. So you need a system, database system, to give you such a kind of insurance. This is what Postgres have done before. So we just take it for example. Okay, so yeah, what we have done for our technology is that we built such a systems in distributed ways, and we also decoupled the computation from the storage So as you can see from this diagram, we are totally different architecture with the traditional ones. In our product, we introduce the concept of node group. Each node group actually operate as a virtual Postgres clustering, and each of the clustering can be extended, can be zooming, can be scaling and scale out. And each of the load can be write, can be read. It's totally unlike the traditional databases, which just only one primary node can write. So we are multi-write nodes architecture. So actually, basically, there are lots of benefits we have gained from the separation of the computation and the storage. If you want to extend the compute resources, you need to add a new compute loader into the systems, and you don't need to care about the storage capacity because it will extend transparently to the customer without requiring any changes to computer layers. So that is totally the separation. I'm not gonna get too deep into the details. Okay, so how can we do the optimization for real-time BI? Basically, there are three things behind the optimization. The first one is we support raw, columnar, and hybrid storage. Each of the storage type can be optimized for specific, lookup scenarios. Like raw-based storage is capable of fast looking up. It can be fast if you just retrieve one or just a few records from the databases. But if you want to do the aggregation computations, then columnar storage would be your best choice. Okay, so also we support the hybrid ones to enable both of the scenarios in combination. Okay, the second one is distributed vectorized execution, because this is something like if you want to do one thing one by one, it's slow, right? But if you employ 7 people or 10 people to do one thing in parallel, the speed will be fast, right? Will be fast. This is such kind of similarity. The third one is data lake integration. We support the integration natively with the data lake like Iceberg. So you can run SQL directly from a database to query the data stored in Lakehouse. Okay, there are lots of details. I'm not gonna go through it because it's too deep. Okay, let's just take an example. Take a real-time, real life scenarios. For example, as you can see here, this is a diagram, right? This is a snapshot of some DEX customers. It looks like a dashboard. But it's more than a dashboard. From the upper part of this diagram, you can see there are lots of trends diagram, right? To show the price, to show the momentum, to show the everything right there. And below the diagram, there are some kind of filters you can choose by the customers. So this is not simple. It will need the data infrastructure to support both faster data ingestion and the transformation. And the most important, faster analytics. Because if you are user of this DEX system, you need to find out the smart money immediately once the transaction happens, right? So, but from the perspective of technologies, you need to ingest the data firstly into the storage system. Then you need to transform the data into the forms, into the results you want, right? To put it into a result, we call it result table. And the OLAP engines then run queries to find out the results from the table. Each of the stage is so hard on its own, but if you put together, it's much, it's gonna be a tough job for any of the systems right now. So how can we address this problem? Yes, you have three options. The first one is you use traditional databases, right? Like TiddlyDB, like Postgres, like MySQL. These are traditional databases. But for traditional database, you are okay with the data ingestion because the traditional databases are role-based. You are able to ingest the data fastly, right? Very fast. But if you lay on the filters on the traditional database, it's gonna be a catastrophe. The performance will collapse. Okay, so the alternative may be the search engine. You may use Elasticsearch or OpenSearch, something like that. Okay, this is we call search engine. It can make your retrieval faster by slice by slice the queries across different shards. Okay, but when the concurrency grows, the performance collapse because of the core technologies used by the search engines. It has some strengths on the performance, so you cannot have the performance as well as the scalability. Okay, so the third choice, maybe you will choose Lakehouse, but as I mentioned before, Lakehouse has many problems. You cannot address most of the scenarios. So there are no best choices. But for us, we Tacnode, in our technology basket, we combine literally these three technologies together with a single engine in a unified platform. So basically, you can think Tacnode as a combination of data ingestion, the ability of data ingestion, data transformation, and data retrieval. We combine them together, provide a unified interface to our users. So 3-in-1, in other words, it's 3-in-1 solution. Okay, so another one is a scenario about the risk control system in Web3. As you all know that every transaction occurs in crypto exchanges. Every transaction will go through risk control systems. Let's say that there are maybe 10,000 of users using Binance, right? Binance concurrently. For a system, maybe there are 100,000 of concurrent seekers in our systems, and each of the transaction may require access to the risk control systems. So in this way, the risk control system may undertake 10,000, 100,000 of QPS. It's a disaster if the system is not designed well prepared for such kind of scenarios. So yes, many customers are facing these problems. Yeah, because as I mentioned, the same story with the DEX scenarios. Every transaction, every data generated by transactions will go through 3 stages: data ingestion, data transformation, and the data retrieval. So no single systems in the world can solve these 3 challenges in just one single platform. Tacnode is the only one in the world that is able to facing these kind of challenges. So let's get back to the risk control systems. You can see here is a Tacnode platform. We combine data ingestion, data transforming, and retrieval into one platform, but separated workloads, separated clusters. the workload between these clusters are isolated. And all of clusters, they are sharing the same storage. You don't need to move data from one storage system to another storage system, which will introduce delays, right? In Tacnode, you don't have such a delays. Don't need any movement. Okay, so this ensures freshness as well as concurrency to the entire platform. So this is what I've done to the risk control systems. Okay, just a recap. There are lots of benefits, lots of advantages by using Tacnode. I'm not going through one by one. Just most of these features I've just mentioned before. Okay. Okay, just I need to summarize in some things. There is a kind of performance you can buy. There is kind of performance you can buy. We can just add more machines to the existing stack, right? This is normal ways. But for the kind you cannot buy, there must be some things you cannot buy in the world, like the true data freshness for Web3 industries. There are a lot you cannot buy the freshness because of the constraints by the technologies. So in this way, you need a new engine. That is what Tacnode do. That is what we are doing right now. So thank you very much. 是你的吧？哦，不是你。但是我好像这个里面好像没有。信息对的，对的。是这个延迟，对的。哦，有延迟。这个直播是延时多久？哦，OK OK。OK。Hello everyone. My name is Hanson Bo. I'm a solution architect from NebulaGraph. Today I will share some contents about knowledge-based Web3 risk control strategies. Here is the outline. The first part will be a quick introduction about NebulaGraph. NebulaGraph is our core product's name, and VSoft is our company's name. VSoft was founded in October 2018. The core members come from Facebook, Alibaba, and Oracle. We are dedicated to the development of NebulaGraph, a cloud-native distributed graph database. The headquarters of VSoft is in Hangzhou, and we have some branches in Beijing, Shenzhen, Shanghai, and Silicon Valley. From 2018 to 2021, we focused on the open source edition. During this period, we have accumulated a large number of community users and polished the product. We released the first enterprise edition in February 2022, and we continue to polish our products with new features, such as the support of AutoMQ and Graph RAG. We have a vibrant open source community, which was officially opened in May 2019. We have already got over 12,000 GitHub stars and over 2,000 forks and over 200 contributors. Welcome to join the NebulaGraph community. Over 2,000 leading innovators choose NebulaGraph, including enterprise customers and community users. In the Web3 industry, Binance, OKX, Blockstack have already used our enterprise edition for on-chain tracking, anti-fraud, and anti-money laundering scenarios. If you are interested in the scenarios of them or how they use NebulaGraph, please don't hesitate to contact me. Okay, the part 2 is what is graph? So when we say graph, it doesn't mean the line chart or the pie chart. It's this. We mean the data structure. So a graph is a data structure consisting of nodes and edges, and every node or edge has a tab and some attributes. For example, if there are two persons named John and Lucy, we can create two nodes to represent them. If there is a company named VSoft, we can also create a node named VSoft. And if John and Lucy are a couple, we can create an undirected edge named couple. If Lucy transferred to John, we can create a directed edge named transfer. And we can add some attributes on the node and the edges, such as birthday, transaction time, currency, or amount. So there are three basic elements in the graph: the node, edge, and the attribute. So how to store, query, or analyze this graph? We usually use graph database. In the relational database, we use table to store data. We query the table via SQL, and relational database has a good performance in single table CORD, but it has a bad performance in multi-joins. But in graph database, we use graph to store data. We query this graph with AutoMQ, and the graph has a good performance in multi-hop query, and it also supports graph algorithm. So the world is a graph. Everything is connected. For example, if in the social networks, when I view some contents or I like some contents, we can create an edge between me and the contents. If I follow someone, we can create an edge between me and the person I followed. But in the Web3 industry, cross-chain transactions are naturally a public huge graph, and we can integrate this graph with internal graph. With this huge graph, we can do a lot of things, such as analyze cross-chain asset flows, identify suspicious addresses and malicious transactions. Let's dive into the part 3, how to use this huge graph. The most popular topic in the Web3 industry recently is the stable coin, whether from the perspective of supervision, business risk control, or other aspects. How to make good use of the existing data. Analysis based on on-chain data is essentially relationship intensive and path-driven. So if you use traditional database or some other tools, you will find it is difficult to model, query, calculate, or visualize this data. There are three main challenges. The first is how to integrate billing scale on-chain and off-chain data. If you use relational database, you can't use one schema to represent all of them, and you can't even store them in a table. The next challenge is how to uncover hidden relationship. You rely on static rules and pre-designed relationship analysis dimensions. If the data is changing with time, you can do this. The third challenge is how to track the flow of funds over 20 hops. The key is performance. You can even do over 3 hops in this huge graph. This is the architecture landscape about how to use graph technology to construct graph intelligence solution for risk control. First, you can create a graph data model to combine all of the data and store them, and use some graph features, metrics, algorithms to analyze this graph. We usually divide the business workflow into 3 parts. You can construct them some scenarios in pre-event warning, in process control, and post-event analysis. For example, in the phrase of pre-event warning, we can use graph metrics and graph algorithms to mark some suspicious groups. And when they contact with other groups, we can take some business measures in time. In the phrase of in-process control, if Zhang San transferred digital currency to Li Si, who is not in the blacklist, but Zhang San and the Tacnode are connected through a few steps away, the transactions can be cut off in time. In the phrase of post-event analysis, we can track the flow of each fund. As we mentioned before, the first challenge is to combine all of the data. Here's a typical graph schema in digital exchange. We have on-chain transaction data, device, IP, user behavior, or some social graph data. The more data you have, the more dimensions you can analyze. We can import batch or streaming data into the graph. The on-chain data include, we can see the crypto address and transactions such as BTC, BNB, or others. The off-chain data, or we call it internal data, include user, email, and IP, and some other data. The scale of this graph depends on the amount of data you have. If on-chain data is added, it is generally at the level of tens of billions. Of course, there are also some professional service providers that provide on-chain data services. At this time, we can use the interface to call the on-chain data. We only need to import the internal data into the graph and mark the wallet or some other information by the external data. The second challenge is about uncover hidden relationships. Let me give an example about how to identify a real person or a group from multi-accounts transactions. We can construct a group with key nodes and edges. For example, accounts, addresses, IPs, devices, and emails. And then we can apply the low-end or WCC algorithm to divide the whole graph into some communities. We can set the weight on different types of edges. If Jack and Lucy are connected through the same email, the relationship between them is weak, and we set the weight of this edge tapped to 0.5. If they are connected through the same home address, we can set the weight of this edge tapped to 0.8. You can set this value as you want. You will get some communities by this graph algorithm. Maybe you will see a community like this. User 1 and user 2 and user 3 are connected through the same home address. And user 1 is in the blacklist. User 4 has no direct connection to user 1. But when we see this topology, we still suspect that user 4 is related to user 1. Perhaps these 4 users are all controlled by the same person or the same organization. You can also use some graph metrics to describe this community, such as black nose ratio or average fraud amount of this community. The third challenge is all about performance. Graph database outperform relational database in multi-hop query. The difference lies in how they gather relationship. Relational database gather relationship by computing, usually by multi-index scan. Graph database gather relationship by reading, usually by pre-storage edge, and only scan relevant data. Here is a test about multi-hop query. The multi-hop latency of graph database is much lower than that of relational database. With this performance, you can do fast multi-hop risk association detection, enhanced raw and real-time decisions. So how do we leverage these advantages in specific scenarios? Let me give 2 examples. The first scenario is batch registration. Traditional solutions may use some data features or to achieve batch registration, relying on expert experience or some static rules, and are unable to identify this behavior in real time, globally, and multidimensionally. If you add graph rules engine, you will get this. When a new user registers, we insert all his information into the graph database and see if he is connected to someone on the blacklist or matches certain high-risk graph patterns. Before running this engine, the paths are not fixed. Therefore, even if the topology of the data changes over time, some graph rules still apply. Alternatively, if we treat risk on a case-by-case basis, we won't see the group risk. If we add graph algorithms, we can find some rules of graph behavior, such as the batch such as the batch of there are some metrics to describe the community. The next example is about transaction risk control. In the Web3 industry, a single individual often controls multi-digital wallets. They can easily transfer digital currency between these wallets. If you are still using a relational database or other tools, you might not even know how to track these wallets and funds in the huge network. We built a risk control graph using phone numbers, IPs, devices, wallet addresses, ID cards, and behavior patterns. For example, if Jack transfers funds to Lucy, we not only check whether Lucy is on the blacklist, but also whether Jack is connected to other blacklisted nodes through Lucy. This allows us to promptly cut off these risky transactions. So how would we build this system with NebulaGraph? I think this architecture would be helpful. The blue parts are offered by NebulaGraph. The green parts are offered by users themselves. It's a hybrid architecture suitable for real-time, near-real-time, and offline processing scenarios. For example, if Jack initiates a transaction, the business system creates an event
and NebulaGraph consumes this event through Kafka, and Jack's information is inserted into NebulaGraph online cluster. The feature platform will run over 100 graph rules to determine whether the transaction is risky. For example, it might determine whether Jack is connected to a blacklist members. This type of risk will have high concurrency and low latency, typically in milliseconds. Data synchronized data will be synchronized from the online cluster to the offline cluster in real time. And we can run graph algorithms in the offline cluster. For example, to generate a small graph containing Jack's 3 hop neighborhoods and run graph algorithms on this small graph. The latency for this small graph is usually in seconds, and multi algorithms can be run in parallel in this small graph. Of course, we can run graph algorithms on the entire graph with latency ranging from minutes, hours, or days. Furthermore, we can explore the graph using a browser and the graph platform, a visualization tool. We know that feature engineering is important in machine learning. Graph database can provide rich features. Graph features are all about relationships, making them unpredictable and reliable. When we use machine learning to label certain individuals, such as over 90 probability of being a criminal, or 2 accounts over 80 probability of being controlled by the same person, we can import this data into the graph to enrich it. The enhanced query, this enhances query and computation capabilities. Next, I will share 2 use cases. This use case is about a top digital exchange. The business background is all about compliance pressure. With billings traded daily, they need to identify suspicious activities in this huge graph, such as money laundering or market manipulation. They built a CSI platform to solve this problem. A criminal insensitive investigation. They leverage NebulaGraph to integrate on-chain and off-chain data, including approximately 4 billion nodes and 40 billion edges. When a case comes in, anti-money laundering experts and risk management departments can easily use this platform to explore fund flows and identify hidden paths between specific individuals or wallet addresses. Next, we will explore how to leverage real-time graph rules and algorithms for in-process control and post-event analysis. This use case is about to label and track on-chain fund flows. They use NebulaGraph to label suspicious addresses. For example, if one address was labeled as risky, all associated addresses would be labeled as tainted. By using NebulaGraph, they can identify addresses belonging to celebrities, criminals, or large companies. The challenge is how to leveraging this massive on-chain graph to label these addresses using graph metrics, algorithms, and features. They provide users with personalized on-chain data services. With NebulaGraph, they can monitor cross-chain fund flows and identify suspicious transaction patterns. Here is the last part about our product. NebulaGraph is the first distributed graph database to natively support AutoMQ. AutoMQ is the second standard query language for database. The first one is AutoCircle. You can import data from multiple data sources, including batch and streaming imports. NebulaGraph can be deployed on the cloud or on premises, running on Kubernetes, virtual machines, or physical machines. Graph data, vectors, and full text search are natively supported. without the need for a vector database or Elasticsearch. We provide multiple SDK. At the visualization layer, you can model, query, and explore data in NebulaGraph. The dashboard is designed for DBAs, allowing you to use this visualization tool for deployment, upgrades, monitoring, backups, and any other maintenance tasks you may need. The Nebula AI application platform is designed specifically for RAGs. Graph is a natural structure for representing context, with which you can combine all graph strategies with large language model. With this platform, you can easily extract graph data from unstructured data, convert natural language into graph query language, and record trunks, nodes, edges, graph structures, and graph summaries instead of recalling trunks from the vector databases. And there are three key advantages of NebulaGraph. The first one is NebulaGraphs share nothing distributed architecture. The storage layer and the computation layer are separated and can be scaled independently. So you can store and compute data at billions or trillions of scale. The second is NebulaGraph's powerful engine that incorporates both TP and AP. And the third one is the cloud native architecture. So you can deploy NebulaGraph on any cloud, such as AWS. And here is a comparison of editions. The open source version is designed for rapid innovation and iteration. The enterprise version offers more features and technical support. So you can choose what you any of them which you like. Yeah. And Graph is the core of this platform, with which you can combine large language model with graph strategies. If you want to know about this, please contact me. Okay, that's all. Thank you.